So tell us about some of the things that are going on at NASA Ames in support of the commercial crew development.
Well, NASA, as many people know, is committed to having commercial space transportation. We're going to rely on it for our low Earth orbit space transportation needs. Now, every center is playing a significant role in assisting that, and I like to think of it much as the way we did with the aeronautics industry in the first half of last century. It was we had an organization called the National Advisory Committee in Aeronautics. Ames was one of the original centers, and we were the second one. We're doing the same thing for space, and that, in short, is to provide technical facilities, technical expertise, and technology. So we're doing that for a number of the commercial space providers. Maybe one of the most important things we're doing is providing knowledge, technology, and capabilities on reentry technologies. For example, the Falcon Dragon capsule rides on pica, which is a material invented at Ames, but there's a lot of other things we're doing too, as well as guidance activities, computational capabilities. We have the agency's supercomputer, but we're doing more than just with commercial space access. We're also doing a lot of things with other commercial space companies as well.
Are you guys, especially locally, helping out to try to do a lot of the sort of unfunded Space Act agreements, and what sort of other smaller business plans have been coming out that accentuate the commercial crew program?
Well, it's important to understand that NASA has a variety of tools to assist industry with, and individuals for that matter, with space entrepreneurial activities. The Space Act agreement is one of the most powerful because it allows us a lot of flexibility to form agreements to provide, in some cases, unfunded. If people just want to come in and chat with us, get information, do a joint collaboration with us that's related to some of our existing work. They do their work for free and we do our work for free, and then we share the results. Now, if they require some additional effort on our part, something we weren't going to do, then we can have a funded Space Act agreement where, and those can go both ways. They can be funded by them to have us do things, or we can fund them to do things to help us. But that's just one of the many tools we have. We can do cooperative agreements, we can give grants, we can do contracts. There's a whole variety of programs that NASA has. Maybe one of the most interesting is really our student programs. What we do is we get a lot of students coming in various programs. They work with us, they work with our technology people, and they figure out something new, and a lot of them go off and form startups. I know of at least 4 or 5 doing startups in the last few years that have worked with NASA Ames.
Has NASA Ames been involved at all in any of the development at Vandenberg to support commercial crew launches from there?
We've been involved in many things, both at Vandenberg, at Wallops, at Kennedy Space Center, and other places. For example, Kodiak. When companies come and talk to us, we provide support. And again, I think the key thing to understand what Ames does is we have real expertise in entry, descent, and landing. So it doesn't matter where they launch from. If they want to bring anything home, like people, they're going to be talking to us. But they also, we do a lot of information technology work in terms of how to control systems, avionics, and so forth. And we have worked to transfer that and work with a whole variety of launch companies. But again, I want to emphasize it's not just launch companies, it's also the payloads and return activity as well. But the other thing that we have a lot of expertise at Ames about are human factors, the ability to interface humans with machines. And that has a lot of interest, particularly when you're going to fly something, but even ground control, which is a big human factors problem. So across the board efforts, I think we probably have 200 or 300 Space Act agreements in force at any given time. dozens of cooperative agreements, many contracts and grants, hundreds to be exact. We also are involved in we actually lead the agency's small business innovative research program. So there's another vehicle. I mean, it's really kind of literally too numerous to mention.
What are some of the proposals and especially plans that have been selected through the SABRE, the Small Business Innovative Research, that you think that might be game changers in the industry, or at least help to accentuate it in some way?
Well, there's a lot of very interesting technologies that I think are truly game changing, and the one that I'm most excited about, frankly, is really small satellites. What we can do with CubeSats and the capabilities there. And we have many different agreements to work on CubeSats to do some really clever stuff. I'm convinced CubeSats eventually can do just about everything that a big satellite can. I know people always used to say, well, you can't do big optics. They're not quite right. There are some ways to use them in an ensemble, to have very, very lightweight optics. So we have a number of programs in CubeSats. We have some spin-offs that have come out of Ames work. There's one that we're working right now that I'm very proud of. That's an international effort with AAC, Angstrom Aerospace Corporation in Sweden. They actually have an office in our research park. We have just completed some work with them on a plug-and-play CubeSat. A plug-and-play is sort of like, so it actually works like your computer, so it doesn't matter what hardware you've got in, if it has the right interface, you can put it together. So we built something called the Tech EdSat based on components provided by AAC. We have shipped that to Japan. It was launched on the HTV-2, which is just now captured at the station. In about a month and a half, it's going to be deployed as a small satellite directly from the International Space Station. It's part of the first group of small satellites, CubeSats, launched from the International Space Station. That, I think, is going to open an immense new opportunity for private sector to do things. We're looking ahead to how these CubeSats can actually carry biological experiments that could be brought back in the atmosphere. We think that you could build these CubeSats in a way that for something that cost a few $1 million, you could send a CubeSat to visit Mars, visit asteroids, do things on the moon, all the things that people are really interested in. And these have immense commercial applications. You know, people are interested in asteroid mining. You want to go visit the asteroid before you figure out what's there.